Welcome again. So in this video, we're going to look at state transformers, and again, so some of the topics that we have covered so far are we have looked at simple transformers using maybe T, and then we looked at list transformers, and after completing list transformers, we're going to now start looking at state transformers. So before we continue this journey on state transformers, at least one of the approaches I'm going to take in this video is going to be pretty much consistent with what I've been doing in the last two sets of videos on transformers, where I'm going to give you some theoretical background, theoretical ideas, and then maybe in the next set of videos, sometime in the future, I'm going to use these ideas to create some maybe practical use cases where you start looking at maybe non-trivial applications where you can start building these ideas a little bit more further. So with that, what I'm going to do now is I'm going to first provide you a, a new type definition here. So it's a new type definition, and what I have here is just basically a wrapper. I just have a wrapper around this type here. So around this type over here that I've highlighted in pink, I have a wrapper. I have a wrapper here, which is my state T SMA, and let's just try to break this apart. Let's just try to tear it apart and see what are some of the obvious that I can at least learn from this type definition. So one of the things I can see is that for my value constructor, if I look at my value constructor state T, which is right here, I can actually define the type signature for my value constructor, and the type signature is I can say state. Let me just be consistent with my uh, cases here. So this is state T has a type signature. It has a type signature that it takes in a value. It takes in a value of the type. Uh, it takes in this following value and as a first parameter, and then it gives you back some value of type state T S M A. So this is just my type signature for the value constructor, and likewise I can write the type signature for my accessor run state T, and this accessor, this method over here, has the following type signature. It takes in some value of the type state T S M A, and it gives you back some value of the following type. Okay, and again, just trying to figure out the kinds for these types here. I know that this must be a concrete type. This entire thing must be a concrete type. This entire thing over here must be a concrete type. And likewise, I can easily assume that this A and this S over here each have a concrete type. And likewise, I can infer that this M at this point, I mean, this M is going to be a monad at some point when I try to make an instance of my monad's type class. When I at that point I'm going to put a constraint on M being a monad. But even without having that knowledge at this point, I know that the kind for M at this point is M is acting as a type constructor, which takes in some concrete type, which is this piece over here. It takes in some concrete type and gives it back as an output another concrete type there. So given this information here, I can easily now find out the kind for state T. The kind for state T is it takes in S, M, and A. The kind for S is a concrete type. That's my S. The kind for M is the following from star to a star, where M is acting as a type constructor, and then A is another concrete type, which eventually, when state T consumes these three parameters, it gives you back another concrete type. Okay, so this is what I have so far. This is what I've just something that I can easily infer from the type definition. Now, what we're going to do in the next video is we're going to use this kind that I've just inferred here. I'm just input this kind over here, and I'm going to see how am I going to use this information, and what is it that I can do to make an instance of the monads type class. Okay, so we'll just tie up some of this material in this video in the next one.